Good afternoon, class. Today we will be talking about perimeter, circumference, and area of some basic shapes. We're only going to be dealing with triangles, squares, rectangles, and circles today. While we will eventually be able to find the area and perimeter of other shapes, that's all we're going to deal with right now. Perimeter. It's the distance around a polygon. What we do to find perimeter is basically just to add up around the edges. Side 1 plus side 2 plus side 3 plus side 4 plus side 5 plus side whatever. Whatever all those lengths will add up to be will be the perimeter. You could also think of it if we were going to enclose that area and build a fence around it, what's the length of the fence I would need? That's perimeter. Circumference is just like perimeter, but it's for a circle, specifically a circle. It's the distance around the edge of a circle. How much fence would I need to cover a full circle? And area is how much stuff will actually be contained within. How much area do I actually have laid out in there? So if I was trying to cover everything with 1 inch of sand inside of my shape, how much sand would I eventually need? Alright, the formulas. For a square, this capital P represents perimeter. This lowercase s represents side length. So perimeter equals 4 times the side length. Yeah, if I would do s plus s plus s plus s, well, when I add up 4 s's together, I will get 4s. So perimeter equals 4 times the side length. Area, on the other hand, it's always going to be base times height, or in the case of a square, side squared. For a rectangle, perimeter will be the width plus the length plus the width plus the length, or when we simplify it, it'll be 2 times the length plus 2 times the width. This cursive L being the length, this cursive W being the width. The area will just be multiplying the two dimensions together, the width and the length. Sometimes you will see these formulas written a little bit differently. Instead of using width, we use height here, and sometimes instead of using length, we use the base. So sometimes you might see 2 times B plus 2 times H, 2 times the base length plus 2 times the height. And for area, you would see base times height. For a triangle, you just add up the 3. So A plus B plus C. That's going to be the perimeter of my triangle every time. There's no simple way to simplify this. It's just add up the 3 side lengths. To find the area, you will have to multiply one side, that's called B here, the base, times its height. There has to be a right angle symbol here, like this one right here. If this wasn't here, you wouldn't be able to say this is the base and this is the height. Please note there's other ways I could have drawn this. If I drew a right angle to this side over here, to side A, it would come from over here, but then this would be the length I multiply A by. It's going to be base times height, but it's got to be across this right angle. And then we take half of it. Side lengths being A, B, and C, the base is B, and the height is H. For a circle, R stands for radius and D stands for diameter. Radius is always going to be from the center of the circle to the edge of the circle. No matter how I draw a radius, all radii of my circle will be congruent. Radii is just a plural form of radius. The diameter here will be something that goes through the center, and is going to be twice as long as the radius because it hits both edges. If I'm looking for the circumference, capital C, it's going to be this number pi. This is a number that we always know. It's a Greek letter, pi. The number is 3.14. It goes on forever, and if you're using the calculator, it will be as accurate as it possibly can be. If I'm asking for an exact answer, you never multiply by pi. You just leave pi in your answer. So for instance, if I knew the diameter was 5, then my circumference would be 5 pi as an exact answer. If I multiplied it out, I'd get 5 point something around 7. Same thing over here, but instead of knowing the diameter, I knew the radius, so 2 times pi times the radius. Either one works for the circumference, it just depends on the circumstance. And the area of a circle is pi r squared. You have to square r before you multiply by pi. If you do it the other way, it's wrong. When I look at this, it says find the perimeter and area of a football field if it has a width of 50 yards and a length of 120 yards. The very first thing I do when I'm given a word problem is I draw a picture. This is my football field. I've labeled the width as 50 yards and the length as 120 yards, and it's a rectangle. If I'm trying to find the perimeter of a rectangle, I have to remember my formula. That's the formula. My length ends up being 120 yards and my width ends up being 50 yards. Let's plug both in. And because they are the same unit, I'm not going to worry about putting them in. I'm just going to add it in at the end. And there we go. That's the perimeter of my shape. 340 yards. That would be how much fence would be needed to build around a football field, or it would be the length of the paint that would be along the edge of a football field. Now, if I'm looking for the area of a rectangle, remember it's area equals length times width. That's the formula. So in this case, I just multiply 120 by 50. And when I multiply these two, it's going to be a big number, but this would be how much grass you could think is covering the surface. And my answer would be 6,000 yards squared. And I am done with example 1. Example 2, the picture is already drawn for me, so I know that I'm going to be pretty nice. The only thing that they really missed was that right angle symbol at the bottom for me, so I'm just going to add that in. Normally you wouldn't add this in if it's not labeled, but it was supposed to be. Much better. And now that I have that, let's actually find the area and perimeter of this triangle. Let's just start with perimeter again because it's convenient. Remember, perimeter is equal to A plus B plus C. In this case, it's going to be 2 plus 2 plus 3.5. Or to put it simply, 7.5. In this case, because it's perimeter, we want to always remember that perimeter should have units. So even though there weren't any given, please write out the word units. Next, to find the area, we will have to do base times height. This will always be where there's a right angle drawn. So in my diagram up here, this right here is going to be the height because it's not a side length. This here is going to be the base because it's a right angle to the height. So my answer will be 1 times 3.5. So my area is 3.5 units squared. Again, I don't know what the units are, so I'm just going to put units in there and squared because it's an area. Example 3 here says triangle ABC has coordinates A 1, 6, B 1, 2, and C 7, 3. Anytime I see coordinates like this, I know that I'm pretty much going to be dealing with a graph like here, and I will have to plot these. It just so happens I'm looking for its perimeter and area, but it still doesn't matter. My first step is still plotting every single one of these points. A was 1, 6, so that's where I'll put it. B is 1, 2. And C is 7, 3. Now all I have to do is be careful about what I'm labeling, and I'm just going to label them real quickly here. For this problem, I'm going to have to do something to help myself out. There's only one length that I can identify pretty much without having to use the distance formula, and that's from A to B. It's a vertical or horizontal line, so therefore I can just count the number of boxes in between. 1, 2, 3, 4. This length over here is 4. The others, I'm not so sure about. I'm going to have to plug them into the distance formula. And let's quickly do that. The length of line segment AC. I chose C to be x2, y2, and A to be x1, y1. So when I plug in this, 7 goes in for x2, 1 goes in for x1, 3 goes in for y2, and 6 goes in for y1. Now that it's all plugged in, I just solve and I'll have the length of segment AC. 7 minus 1 is 6, and 3 minus 6 is negative 3. Squaring both of those, I get 36 plus 9. At this point, I just add them together. I'm going to get the answer of square root of 45. Because I'm going to be eventually looking for the perimeter, I would probably just plug this in my calculator. And when I punch in my calculator, I actually get 6.71. Do the same thing for length of line segment BC. And when you get all done and said, you get the square root of 37, or 6.08 when you round. And now when I'm looking for the perimeter here, all I'm going to do is add up all three of my side lengths. 4 plus 6.08 and 6.71. So my perimeter here is going to be 4 plus 6.08 plus 6.71. When I add all three of those together, I'm going to get 16.79 units. I know it's a little bit hard to read, but that's 16.79 units for the perimeter. For the area, I'm going to need the height. But the height of this shape is only going to be from the vertex to one of the sides. The easiest side to go with would be something that's perpendicular to a vertical line. And I just so happen to have a vertical line here, so what if I would connect this side to this vertex over here? If I did that, I would have the base and height of my shape, even though I might have to tilt my head to see it the way I'm used to with my base and height. When I count up the number of squares going horizontally here with this right angle, it's 1, 2, 3, 4, 5, 6. The base of my shape is going to be 4. The height's going to be 6. The area of my triangle is just multiplying the 2. 4 times 6, which will be 24 units squared as my answer, and I will box it up. Don't forget to add the square, otherwise it will be wrong. And that's how I would do a problem like this. Example 4 says find the circumference and area with a diameter of 10 inches and a center C 5, 7. I messed up here. It should have said find the circumference and area of a circle with a diameter. However, the word circumference gave it away that it is a circle. Only with a circle can we use the word circumference. So when I look at this, I'm just going to draw a center, 5, 7. Now if I'm going to try and draw the circle, it said it had a diameter of 10 inches. That means its radius is 5 inches. If I let each one of these numbers up here be an inch, I can just go 5 to the left, 5 to the right, 5 up, 5 down to draw my circle. And then from here, you just make an arc to connect the two dots. You're going to want to start shallow and then eventually grow, make it steeper so that way it ends shallow also. If you do this correctly with all of them, you should get something that looks relatively close to a circle, even if it's not entirely a perfect circle, which it generally will never be. If you do it correctly, it'll look like a circle. The only one that I'm going to label here is 5, 7. And I would probably do something like this to let people know that its radius is 5. Truth be told, I didn't have to graph it. But now that I see it, it makes sense to me. I see clearly what its radius is, what its diameter is. I actually have something to look at. I didn't have to do that at all for this problem. The circumference has an equation, pi times diameter. All I have to do is plug in 10 for the diameter and multiply it by pi. 10 times pi, my answer, if I was going for an exact answer, would just be 10 pi. However, if I was going for a decimal answer, I probably would ask for 31.4, in this case, inches. Depends on if I was asking for exact or if I was asking for a rounded answer. If I don't make it clear, it's your choice. With rounding, go to the 10th or 100th, where appropriate. For the area of the circle, I would need the radius, which is just half of the diameter. I've already said that it's 5. Over there you see the diameter is 10. I could have just said 10 divided by 2 is 5. Area will be pi times 5 squared. Same thing as before. I could leave my answer as 25 pi inches squared, or I could plug that into my calculator. 78.5 inches squared. Because leaving pi in is more of an exact answer, if I didn't specify which way, I would probably prefer you just leaving it in the terms of pi. However, if it's a word problem, please round. This is not really a word problem, even though it has mainly just words. But if it was a real world application problem, round. Most cases when it's a real world application, the rounded answer will be more applicable. At this point, you should be able to find the perimeter and area of a triangle, rectangle, and or square. And you should also be able to find the circumference and area of a circle. Till next time.